we have the option. From this side of our dot, we could go up, or we could go up through the asymptote and then be sucked along the asymptote. Because remember, you're always being sucked towards your asymptotes. Kind of like a black hole. Or we're just going to go up and skim along the asymptote. Well, I know it's going to be the bottom one because I don't cross my asymptotes. Remember, we found out there's no cross touch point. So it cannot be this option, which means it's the bottom option. So, on the right side of our dot, we have two options. We can go up, cross, and follow the asymptote, or go down and follow the asymptote. I know it has to be the bottom one because I don't have a cross touch point. Okay, so there's no way I could have crossed my asymptote. Okay, and that's how we did that side. So that was the one branch of my vertical asymptote. Let's check the other side. Problem is, I don't know if my graph is going to be above or below. So what we're going to do is find a test point to see where my graph should be. I'm going to pick maybe, let's say 3. I could pick 2, but I want to pick 3 and see if it's going to be above or below. So plugging that in, that's going to be 3 minus 1 times 3 minus 1. Aha, it's a negative, so we're going to be over here. So my graph, let's do the same thing on your point. You can do left and right side. On the left side of the point, we could go up through the horizontal asymptote to follow the vertical, or we could go down. 2 options. Which one do you think it is? It can't be the top one, because if it is, we'd be crossing the horizontal asymptote. So no can do. It's got to be the bottom. Next, with the dot, we could pop up through and then follow the asymptote, or we're just going to skim on the bottom. Same reasoning as before, we do not have a cross touch point there, so it's got to be the bottom option. And there we go. That right there is the graph of our rational function. All right. Okay, another one. Let's go ahead and graph this one. I would take a second, see if you can graph this one by yourself, and then check in with me. All right, so first things first. Let's find that domain. So we're going to factor everything, top and bottom. So let's see, I'll do 1 up here. So y is going to equal factoring the top and bottom. It's an ugly x, okay. Okay, from that, let's see, the values we can't have are -1 and 2. So the domain, we're going to take out -1 and 2. So negative infinity to -1, union -1 to 2, union 2 to infinity. Vertical and horizontal asymptotes. So vertical asymptotes, simple, picking them from the bottom. We know that, oh, we have 2 this time. Interesting. So x cannot equal 2, and x cannot equal -1, so we've got 2 vertical asymptotes. Horizontal asymptotes. Well, let's compare our powers of our polynomials. We have a 2 and a 2. Since they're the same, we're going to take the ratio of their coefficients, which is 1 and 1. So 1 divided by 1 is 1. So our horizontal asymptote, y equals 1. So we do not have a slant asymptote because we have a horizontal asymptote. All right, let's check to see if we have any cross touch points. Okay, so setting our horizontal asymptote equal to our function, we'll get 1 equals x squared minus 2x plus 1. Okay, cross multiplying. Okay, the x squareds cancel out. See, adding the 2 to both sides, that's going to be 3. Subtracting. Ah, x equals 3. So we have a cross-touch point. So our cross-touch point is going to be, well, the y value was 1, and the x value we just found was 3. So we have a cross-touch point at 1, 3. Let me just make sure that was right real quick. So let's see. Yeah, adding 2x, that'd be 1. Minus adding 2. Yeah, awesome. All right. So let's see. Next step, intercepts. So for my x-intercept, solving y to 0. Cross multiplying. Okay, let's factor. So x equals 1. That's my x-intercept. I just realized this is why it looks strange to me. I put these guys in the wrong place. Let's just do 3, 1. All right, sorry about that. Okay. And then y-intercept. Something about that one was bothering me. Finally figured it out. Okay. Let's see. So y-intercept, set all the x's to 0. 0 squared minus 2 times 0 plus 1. All over. Let's see on the bottom. 0 squared minus 0 minus 2. All right, so we're left with y equals negative half. So we have 0, negative half. All right, so let's go ahead and plot all of this stuff in. So my asymptotes, I'll put them in purple. We have 2 for the vertical. Labeling it, x equals 2, negative 1, and x equals 2. Horizontal asymptote at 1. And let's see, intercepts. 1, 0. And let's see, y-intercept, 0 half. Cross touch at 3, 1. All right, so let's go ahead and, so now I have 3 vertical asymptotes. That means my graph has been split into 3 sections. 1, 2, and 3. Let's start from this side. I'm going to pick a test point, because I don't really know where my graph's going to be. Okay, so let's pick a test point of negative 3. So plugging that in, I'm going to use the factored form when I plug it in. So negative 3 minus 1 is going to be negative 4 times negative 4 all over negative 5 times 2. That's going to be 16 all over negative 10. That's going to be a negative number. Wait, that should be a negative 2. It's going to be positive 10. That's going to be a positive number. Okay, so that means we're going to be up above here. Somewhere, let's see, 16 divided by 10. That is, let me see if I can get a decimal out. .6. Oh, okay, so it's above our horizontal asymptote. Good to know. So the y value is going to be 1.6. Oh, no, wait, that is a negative. I don't know why I thought that. Too many symbols going on everywhere. Okay, 1.6 and then 3. Wait, I need to do this one again. Alright, let's do this again. So we pick the x value of -3. Plugging this in, that's going to be -3 minus 1, so it'll be -4. Then another -3 minus 1 would be -4. Then -3 minus 2 would be -5. -3 plus 1 is going to be -2. Alright, so after plugging that in, those are the values we're going to get. So that'll be the 16 over 10, the positive 1.6. Very good. Okay, positive 1.6, -3. About there. Alrighty. Whew. Too much confusion. Okay. So, left to right side of our dot, we can go that way, suction to the asymptote, or we can pop through and come back and get sucked to the asymptote. But we know there's no cross-touch point near there, so it can't be the bottom option. Now let's look at the right side. We can go up and get sucked to the asymptote, or we could go down, pop through the horizontal asymptote, and get sucked to the vertical asymptote. Can't be the bottom one, so it's going to have to be the top one. Alright, let's take a look at this next dot. So, option, we can go up, cross through the horizontal asymptote, and continue, or we can go down. Well, we don't have a cross-touch point there, so it's going to have to be the bottom option. Okay, then we know that this guy, somewhere along the line, joins in with this one. And then, either up or down. Well, it's going to have to be the down option. We don't have a cross-touch point there. And there we go. Alright, so now the weird thing about this cross-touch point. Okay, so option, we could go up or we could go down. It cannot be the down one. You know why? Because we'd have to be crossing the x-axis. And right there we know that there is no x-intercept at this point. So it cannot be the down option. The next question is, does it come up and along? Or does it come from the bottom and along to the vertical, so the horizontal asymptote? Well, I don't know, so I'm going to have to pick a test point and see what value I get. So let's pick maybe 4. So plugging that in, that's going to be 4 minus 1, which is 3. And 4 minus 1 again, 3. 4 minus 2 is 2. 4 plus 1 is 5. So that's going to be 9 over 10. Well, 9 over 10, that is less than 1. Which means the option we actually have is it goes through and then continues to get sucked to the asymptote on this side. And I don't know what it looks like. It could be a very small, subtle getting sucked to the asymptote, or it could kind of loop out. I do know, however, that it does not cross the it does not cross the x-axis. Okay? But it is below at some point. And then it gets pulled back towards our asymptote. Because remember, we're always getting sucked towards the asymptote. Treat it like a black hole. Alrighty. Woohoo! Lots to do there. Okay. Next one. Okay, so slant asymptotes and the end behavior. So slant asymptotes are what we would have instead of a horizontal asymptote. So, if we're looking at our function, and we see that the degree of the top polynomial is 1 plus the degree of the bottom polynomial, then we use long division to find the slant asymptote, the equation for the slant asymptote. Okay, so let's see this. My top polynomial's degree is a 2, and my bottom polynomial's degree is a 1. So, this top is 1 more than the bottom, which means I'm going to have a slant asymptote. Okay, so let's go ahead and graph this one. Same thing, that we got to find the domainer. The domain, everything but 1. And nice and simple, I've been able to find my vertical asymptote, which we can't have it be 1. Alright, so But when I check to compare the degrees on my graph, I find out that the top one is greater than my bottom degree by 1, which means instead of a horizontal asymptote, I will have a slanted asymptote. Okay, so a slanted asymptote, well, how do we find that? Long division. Okay, so let's do that. So doing long division, okay, so how many times can x go into x squared? Once. So subtracting, that's going to be x squared minus x. Those cancel. Negative 3 minus negative x is going to be a negative 2x. How many times can x go into negative 2x? Negative 2. All right, multiplying that out. Negative 2x times positive 2. Those cancel, and we're left with negative 2. So remember, we ignore the remainder, and all we focus on is what's at the top. That is the equation of our line. So for a slanted asymptote, we have the line y equals x minus 2. All right, now next, let's see, do we have any cross touch points? Let me just, too messy. Okay, 3 cross touch points. So we'll set our slant asymptote equal to our function and check. Slant asymptote is x minus 2 equal to our function x squared minus 3x multiply. So cross multiplying. Okay, these guys cancel. And we're left with 2 equals 0, which is not a true statement. Therefore, we don't have a cross touch point. So cross touch, none. All right, next step, for intercepts. Okay, let's cross multiply to solve for x. Ooh, looks like we have 2. All right, so we have 2 x-intercepts. Let me go ahead and make some more space for those. Ooh, that's a long bit of whiteout right there. Okay. So x-intercepts, we had 2, 0, 0, and 0, 3, 0, excuse me. All right, let's do y-intercepts. Okay, make x 0. Okay, so f of 0 is going to equal, make everything to the 0. That's an x value. And what do you know? We get 0. So x-intercept is 0, 0. All right, let's go ahead and graph these, graphing the vertexes, or sorry, the intercepts, sorry, asymptotes. First, let's graph the asymptotes, these two right here. And remember to label them with the equation, x equal to 1. So, slant asymptote, how do we graph that? Just the way we graph a normal line. So our slope is 1, and our y-intercept is negative 2. So negative 2 with a slope of positive 1. Down 1 over 1, down 1 over 1. Okay, that looks like enough to graph it in. And y equals x minus 2. All right. So let's go ahead. What are my intercepts? Well, my intercepts, I have 0, 0. And then 3, 0. Okay, so my vertical asymptote has halved my graph, 2 sides, 1, 2. So